Four statements for the first block. Do they say frictionless, or they don't say anything, do they? Yeah, so I'm assuming there's friction. We have Fn, we have F1G, and then we have tension. This tension is going to be the same throughout this entire string. Is everybody cool with that? Does that make sense to you? Okay, then this one, this is going to be 2T. This is going to be F2G. Because how many strings are lifting up on that block? There you go. Okay, from that we get that T is F2G over 2, and then I can plug it in over here. If I do some of the forces in the X is equal to MA, some of the forces in the Y for this one are 0, obviously. Oh, just kidding, I lied. I'm a liar. Sorry. This one, this should be accelerating this way, right? And do you realize that this one should be accelerating at A over 2? Because if this moves a distance x, like that, when that goes to there, do you see that if the string moved a distance x, does that make sense? Well, do you see that a distance x going around here, this only goes x over 2. When this string lets out x, this one only goes down x over 2. Do you see why that is, logically? Oh, man. I don't know if I can pause. That's annoying. How do I explain this? Okay. If I have a string over a pulley and it's hooked to a box here, then I think it's clear to everyone that if I pull down 1 meter here, this box is going to go up 1 meter. Okay, but if I flip that system around and I have a string connected to the roof and it comes down to a pulley that's on a box, or that pulley that's hanging from the rope, and I have the other piece of rope like this, right? So it's like I'm holding it right here. When I raise this 1 meter, do you see that the rope, the string, has to travel down and up again? So the string travels like 2 directions at once. So it's kind of like twice, but it can only go half the distance because half of it's going down, half of it's going up. So when I pull up, the 1 meter here is only going to get me 1 meter on the bottom. And the reason is because the pulley moves and the string has to go around that corner. When I connect it over a rope to this and pull it down, then it's a 1-to-1 relationship. Okay, well, I wonder if I should look at the solution, see if I have a better way to explain it. Well, let me go through. It'd be a pisser if I was wrong. Oh, well, anyways, I'll try to go through this, and then I'll see if there's a different way that they explain it, and then we'll spend some more time at the end because I can't pause the recording, which is annoying. So then, if that's true, if we just say, okay, that's true for now, and we'll go back into it again later, then what that says is that F2G minus 2T is equal to M2 times A over 2. So if we assume that the thing on the pulley is moving at A over 2, does this statement make sense to you all? Or no? No. Okay, what's pulling down on the hanging one? No, the hanging one. Gravity. Right, gravity. That's F2G. It wins. That's why it's in the positive C. What's pulling up? Well, these 2 ropes, right? So that's the 2T, right? It's like if this was you, right? And then this is 2 other people fighting you, like pulling on a rope or something. Like it's like you minus their force. You see that? And then what is the result? The result is this MA over 2. Because the result's always MA. And we're assuming that if this is A, then this is A over 2. M2 is the weight, yeah. It's just M sub 2. It's just the name. Okay, and then from this, I get T minus mu. Oh, sorry, I should do this out the right way so people don't get confused. T minus F sub F is equal to M1A. Of course, over here, we get f sub n is equal to f sub g. So we get t minus mu f sub n equals m1a, or t minus mu m1g equals m1a. And of course, I can move this over here to plus, whoops, to plus mu m1g is equal to t. Over here, I can solve for t and say t is equal to m2g minus m2a over 2, and then divide this by 2 and make this a 4. Okay, I'm rushing because I'm thinking I'm running out of time on the limit. This is just algebra, and now I can set these two equal to each other. m1a plus mu m1g is equal to m2g over 2 minus m2a over 4. And so then I can now solve this. I can say m1a plus m2a over 4 equals m2g over 2 minus mu m1g. Factor out the a, and I get m2g over 2 minus mu m1g all over m1 plus m2 over 4. Good God, that's horrible. Do we know the relationship between those two masses at all? I don't think so, right? It would be nice if one was double the other. That would be cool. Yeah. Because I can't go anywhere with this, right? I'm stuck. So then whenever you're stuck, ask yourself, do I know what this is? Is there something I can substitute to move on? I say, f sub f is mu f sub n. When I get to here, I say, oh, I'm stuck. But then I say, can I substitute? Wait a minute. Over here, I can substitute this. And now I substitute in fg for that. And we know that fg is equal to mg, right? What? Because that's the definition of f sub f. I think it should be on your formula sheet, like f sub f is mu f sub n, or mu is f sub f over f sub n, something like that. All right, I'm going to try to stop that.